Welcome everyone. My name is Sarah Carr and I am with OCTO. OCTO is an organization that accelerates ocean conservation by connecting ocean professionals to the knowledge and networks they need. OCTO's services include the EBM Tools Network, the Skimmer on Marine Ecosystems and Management newsletter, the MPA News newsletter, MarineDebris.info list, as well as OpenChannels.org. We're very excited today to have a great group here to talk about fostering ecosystem approaches in fisheries management, the Case of Atlantic Menhaden. And we're co-hosting this with the Lenfest Ocean Program. Before we get started, and I turn it over to the Lenfest organizers, I wanted to let everyone know how to ask questions. We'll have an initial presentation by our panelists, and then we'll open it up to questions from the audience. But you can go ahead and send in questions at any point. You can send them in through the Q&A panel in your user interface, or you can send them in through the chat. The chat is open for comments and questions and information provision by all attendees. We just ask that you use it respectfully. I'll turn it over now to Emily Knight, who's the manager of the Lenfest Ocean Program. We're thrilled to be able to host this webinar with her.
Thank you, Sarah, and we're super happy to host this with you. Yeah, thank you everybody for joining us today. We're going to have a great presentation on fostering ecosystem approaches in fisheries management using the Case of Atlantic Menhaden as an opportunity to reflect on how to do that. We'll have our speakers are Dr. Andre Buchheister of Humboldt State University, Dr. Dave Chagaris from University of Florida, Dr. Daniel Howell from the Institute of Marine Research, and Dr. Karen Abrams from NOAA Fisheries. And we're also going to have a brief introduction by my colleague, Jason Landrum, who is a program officer with the Lenfest Ocean Program. He manages our wildlife and ecosystems portfolio, which we funded some of the Menhaden work that we've supported in the past under. And he will say a bit about the portfolio as well as
I don't know if maybe you can help me understand.
Somebody needs to mute themselves, I think. Thank you. Anyway, he's going to say a few words about the portfolio as well as its future directions. And so all of our contact information is up here. We totally encourage you to reach out to any of us, either about this presentation or about the portfolio going forward. I will also drop into the chat while Jason is speaking a link to the papers that are being discussed in the presentation today. There were 4 papers that were published in Frontiers in Marine Science that focus on this case study, as well as ecosystem approaches in fisheries management. And I'll put the link in the chat while Jason is talking. Jason, I will turn it over to you.
Great, thanks so much, Emily, and hi everybody, and welcome to the session today. Thanks for joining us. As Emily mentioned, I'm Jason Landrum, a program officer who manages the wildlife and ecosystems portfolio for the Lenfest Ocean Program. And this is it's exciting to see more, to be a part of this session and to see some of the research coming out from this project and how impactful it's been in menhaden management. But more broadly for our portfolio, as everyone on this call likely knows, over the past several decades, marine fisheries managers have started to shift from managing individual species to considering dynamic interactions between multiple species at the ecosystem scale, namely ecosystem-based fishery. Since 2016, Evfn has been a area of focus for the Lenfest Ocean Program in my portfolio. And we funded multiple projects in this area, primarily to help managers access available scientific data and tools that can be used to assess the status of both species and ecosystems, and to formulate long-term strategic and short-term tactical plans for sustainable fisheries management. This includes some of the research, as I mentioned earlier, that we'll hear about in today's panel session with our great set of panelists. In terms of integrating ecosystems into Atlantic menhaden management. While this previous work that we funded in the past has been successful, additional support is required to advance this field further. That being said, our program intends to continue to support work in this area along two major lines within my portfolio. The first is to expand the development and application of methodological approaches that incorporate ecosystem scale information and perspectives, but remain practical in application for management, very much like the work that's being presented today. The other area that we're scoping currently is also in the area of advancing innovative approaches to assess and manage fisheries and ecosystem, whether it's to improve the accuracy of stock assessments and forecasts for marine species, or developing indicators of ecosystem health or structure and function. Those are the two main areas looking forward that we hope to scope more in this area of ecosystem-based fisheries management and research to help support advance this field. Given that we intend to continue to support research in this area, we'd welcome feedback from you on how to build out this work, especially in terms of the research needs in this area and how to address those research needs moving forward. So as folks listen to the presentations today and participate in the Q&A, please feel free to reach out to me directly if any discussions spark ideas about existing research needs and applications in the field. Thanks again for joining us today. And with that, I'll pass it on to Andre to start our panel session and to learn more about their work to advance EBFM for Atlantic Menhaden management. Andre?
Great, thanks, Jason. Yeah, so I'm just going to be providing a little bit of an overview and an introduction. A lot of work has gone into this, and we're just going to be touching on a few points. There's so many people to thank and acknowledge in this interdisciplinary effort. And Dave Chagaris will be presenting next. We'll have an acknowledgement slide from our side of the Menhaden work. So I'll leave that to him. But as was stated, you know, I think we've done something really interesting moving towards this ecosystem approach to fisheries management for Atlantic Menhaden. So first, for a brief overview of Atlantic Menhaden, many of you are familiar with this species. They're really important schooling forage fish within the Northwest Atlantic. They really play this vital role in transferring energy from lower trophic levels to higher trophic levels. So they feed on zooplankton and phytoplankton, detritus, and they're a primary prey for lots of fin fishes, things that themselves are harvested and play ecological roles. They're also consumed by marine mammals and birds, lots of different organisms. So they play a key role in the ecosystem, and they're found throughout the east coast of the U.S., from Florida up and beyond Maine. Although the concentration of the population and of the fisheries tend to be more in the northern part, kind of from the Outer Banks, North Carolina, and up. So the fishery for Menhaden is actually the largest fishery on the East Coast, as you can see from this plot in the middle here. And this has been the case through time, right? Biggest component of landings. Now, the fishery is broken up into two components. Approximately 75% of landings are what are termed the reduction fishery. So purse seines are used to harvest schools of Menhaden, and they're processed into fish meal and fish oil and used in a variety of products throughout the globe. And approximately a quarter of the fishery is what's termed the bait fishery, where fish are sold whole. Now, the species is managed by the Atlantic States Marine Fisheries Commission, and they have had a challenge in front of them. Right, because Menhaden play this role not only in supporting a directed and large fishery, they also serve these other ecosystem services of feeding predators, transferring energy. And so there's been a big push and focus on developing ecological reference points. This is moving beyond the single species biological reference points. These reference points account for the role that these fishes play as food for larger predators. So the history of menhaden management is long and it's complex. And one of the papers that we just put out, Anstead et al. 2021, has this nice figure that presents some of the highlights, both in terms of what's happened with management and what's happened in the scientific arena. And so I'm just going to touch on a couple things. So ever since the first fishery management plan was established in 1981, there's been this acknowledgement of menhaden as food for other organisms. But the first ecological objectives were only officially and explicitly included in 2001 into the fishery management plan. Now, one of the key steps in the process, I think, was in 2012 when a working group known as the ERP working group was formed. And this was a modification of a pre-existing multi-species group. They were tasked with developing ERPs for this species. And that group has really been pushing things forward. One of the challenges for that group of technical folks, of scientists, was knowing exactly what do managers want, what are the objectives, particularly when we're talking about these trade-offs in how to manage the species. So another key moment was in 2015, when there was a workshop that brought together fishery managers, fishery representatives, and scientists, and they spent 2 days talking and really identifying explicitly what are the objectives in an ecosystem context for this fishery. And you can see the main fundamental objectives listed here. So sustaining menhaden to provide for fisheries, sustaining menhaden to provide for predators, providing stability for all types of fisheries, and minimizing risk due to changing environment. For each of those objectives, a variety of different performance measures were identified. Now, the ERP working group had already been proposing modeling methods to address the manager's needs. And that's what's listed here on the rows. These are different models ranging in complexity from simpler single species models to a full ecosystem model. And then we can match up how well do each of these methods, how well can they achieve these performance measures and identify and quantify these things. And notice that the ecosystem model is the one that can really start to address some of these trade-off questions related to providing for predators. I'll provide a little bit of an introduction to that model in just a minute. And in 2015, the same year as that workshop, a benchmark stock assessment was conducted, and as part of it, there was this ERP roadmap that was established. It describes some of these modeling methods and how to move forward with developing ERPs. So then in 2017, I published a paper on this ecosystem model, and then that was one of these models in consideration. And then in 2020, this is where things really clicked. And after a lot of effort from lots of people, ERPs were formally adopted in the benchmark stock assessment that occurred in this year. And Dave Chagaris will be talking a bit more about exactly how that was done and how these ERPs were developed. But first, let me lay a little bit of the groundwork for this ecosystem model. It is known as the NWACS model, which stands for the Northwest Atlantic Continental Shelf model. This is developed using EcoPath with EcoSim. And the spatial domain is what you see plotted here on the right. So it includes these 4 shelf regions, but also the estuaries and nearshore waters throughout this region. Now, the trophic structure for this model is quite complex. You see a snapshot of the food web here, organized by trophic level. And so we have 61 different trophic groups, and this ranges from phytoplankton down at the bottom to whales and sharks and large finfish apex predators. And you can see menhaden here they are actually consumed by a third of the modeled groups that we have. Now, the model is fit to data that we have from all different sources, from research surveys to stock assessments to literature information. And the model's fit from 1982 to 2017. We do the best job we can capturing historic trends, and then we can use the model to project forward in time. And so, as an example, when we're projecting forward in time, we really want to know, as we change the dial of menhaden fishing mortality, what happens to predators and the rest of the ecosystem. So here's an example of output focused on striped bass, where we can see through time, the black dots are the observed biomasses for the species, and the line is the model prediction. And then when we project forward, we can say, this is what we expect striped bass biomass to look like under a different fishing mortality for menhaden. And we can do this for all species in the model. Now, the ERP working group was focused on certainly menhaden, but a subset of the species, specifically striped bass, weakfish, bluefish, and spiny dogfish. Those were the focal predator species. And then they also were interested in Atlantic herring as an alternative prey to menhaden. So the NOAA model can provide this whole ecosystem perspective on how things are changing. And an example of output that I think summarizes things really well is shown here. I call this kind of the winners and losers plot, where on the y-axis, you can see the biomass relative to the status quo biomass, with different lines representing different groups within the model, just a subset of them. And the x-axis is a multiplier of the menhaden fishing mortality. So as you move to the right, you have stronger and harder fishing on menhaden. And what we see from this analysis is that certain species have a really strong negative response to menhaden fishing. So certainly menhaden, with the black line here, is impacted as we fish them harder. But striped bass in green was another strong responder, as well as nearshore piscivorous birds. In terms of the other focal species that the group was interested in, things like bluefish and weakfish, a lot of those had very minimal responses to increased menhaden fishing. And what this allowed us to do was to identify striped bass really as the most sensitive predator to menhaden fishing. And that allowed us to focus in on that one species that as a representative for the broader ecosystem. And so this model is very complex. And Dave Chagaris led an effort to kind of simplify things down and make the model more nimble for management applications. So I'm going to pass it off to him to describe how he developed another model building on this foundation. So Dave, I'm going to pass it off to you.
Thank you, Andre, and thanks for the nice background and overview. So just a little bit of background about myself. I was a member of the ASMFC ERP Work Group. I think I joined that committee back in 2014 or 2015. So I wasn't a part of it from the beginning, but I have been a member on it since then. And Andre, if you'll go ahead and go to the next slide. And so I was there for all of these when we started putting together these models for consideration. And actually, I think when Amendment 3 was first adopted, we had a couple of models on the table. Andre's model had just been published, and the surplus production model with predation that Jim Uphoff and Alexi had developed was also already prepared. And so we were considering these models, and then we had a surplus production model with time-varying R, as well as a multi-species statistical catch and age model. And I'd say that we kicked those models around for about a year and a half, and then sometime around early 2019. As we were sort of getting closer, after we reviewed all these models and sort of evaluated their strengths and weaknesses, it kind of dawned on me that we were missing something. the first three models provided some advice, but they weren't able to address the feedbacks of menhaden to predators. So they weren't really able to address one of the primary ecosystem management objectives that were stated at the workshop. But the ecosystem models, the ecopath with ecosim models could. However, just listening to being a part of the conversations in the work group meetings, there was a lot of concern about the uncertainty in the full ecosystem model that Andre presented, because there's a lot of groups in that model that we don't have good information for. And we knew that that could be a major hurdle when this thing had to pass peer review. And also there was concern with the full model about, were we going to be able to update this model routinely and within the assessment and management timeframe. And so at that point in time in 2019, I proposed this mice model. And the species that were included in that mice model that Andre mentioned before were selected based on their dependence on menhaden as well as their importance to managers. So if you'll go to the next slide, Andre. And so there are several advantages from going to a simplified model. So we took Andre's full model and condensed it down to 17 groups. And so a lot of species we just got rid of that weren't relevant to menhaden, and then we aggregated a lot of other groups into like invertebrate groups, and focused on these menhaden, striped bass, weakfish, bluefish, dogfish. We ended up adding herring and Atlantic and bay anchovy as alternative prey items. And there were several advantages. As I mentioned before, we removed a lot of the uncertainty out of the large model, and we were able to focus more on the key species that the commission was interested in. Made it much easier to update within the assessment and management timeframe, and also was much more computationally efficient, which I think had a lot of advantages when it came time to doing different model fitting strategies and diagnostics. Next slide. And so one of the things that we decided early on with this model, most ecosystem models would try to fit to outputs from the stock assessments, which we felt might open us up to some criticism, and so we didn't want to bias our results based off of those stock assessment outputs. And so instead we fit to the same fisheries independent or fisheries dependent time series that were used in the stock assessments. So we tried to use the same data streams in the stock assessments. Those are the same ones that were used in the statistical catch and age model and in this mice model. Because we had a simpler model, we could run it with a much faster, and we were able to develop a more standardized approach to calibrating the ecosystem model. And I think that helped us in peer review. And in total, we ended up evaluating 32 different ecosim models. And those models have different parameter configurations that reflect different assumptions about predator switching or compensatory responses of menhaden, and some of the strengths of the predator-prey interactions. And you can, I think, click the next button there. So here you can see the fits. The first slide was the fits to the abundance indices, and we fit the model pretty well to those time series. And you may see in some cases we didn't fit well, but also our fits were comparable to what the single species stock assessment was. So the graph on top there is showing the fit from the stock assessment of striped bass to the MRIP catch per unit effort index. And you can see in the top right corner from the ecosystem model that we're basically capturing the same trend. So our model was performing like the stock assessment. So now we felt comfortable that we had all these species integrated, and they were behaving with the same dynamics as the single species assessments would indicate, but they're actually linked together through the trophic interactions. And then there were another suite of diagnostics that we looked at to make sure that there weren't any parameter instability issues that we did come across as some of the values were hitting bounds. And so we selected the best model based off this fit, as well as how they performed in some of the other diagnostic checks. Next. Okay, that was just showing the fit to catch. All right, so back to these reference points objectives. So we had done all this modeling work, and we were still trying to figure out, what is an ERP? I mean, I think we had several meetings where we just, even though we had been given the objectives, we still didn't actually have a metric. And so as we started kind of thinking more about what the ERP metrics should be, and we went back to those objectives, they asked, one of the objectives is to sustain menhaden to provide for predators, but they didn't tell us which predators and at what levels to sustain them at. Based off of the work that Andre had already done, we sort of started to gravitate towards striped bass because it was the most sensitive of all the predators. And it was also, kind of the poster child for Atlantic States management. And we knew that linkage is there. Striped bass and menhaden is really important. And so we started focusing on using striped bass essentially as an indicator species for the ERPs. But we also recognize that in doing this, there's no single correct answer, but it's actually a continuum of solutions along this trade-off frontier that depends on, and where you want to be on that trade-off frontier depends on how you value the different components. And so we set out using the MICE model to try to highlight that trade-off frontier. Next slide. And so the ERPs were developed using the MICE model. This is similar to the plot that Andre just showed, where we ran 40-year projections over a combination of striped bass and menhaden fishing mortality. So here you see menhaden F iterated at different values and the projected biomass of striped bass at those different levels of menhaden F. Next. And we took those terminal year estimates of biomass when they had come to equilibrium after the 40-year projections and plotted those terminal year biomass as a surface plot. So now we have menhaden F on the x-axis and striped bass F on the y-axis. And what's in the surface plot is the striped bass biomass ratio, so the biomass over the B over B target. And so the two lines there indicate the points where the biomass is at the threshold, and everything above it in red is below the biomass threshold. So that's where you want to avoid going for striped bass. And then the second line is the biomass target line, and everything below that represent combinations of menhaden and striped bass that would result in striped bass being above the target. Next slide. And so if we look at the current fishing mortality rates for these two species, and this is current as of 2017, which was the terminal year in the assessment. Under the current F, the horizontal dotted line there for striped bass, the biomass would remain below their threshold value across all menhaden fishing mortality rates. And this is consistent with the striped bass stock assessment that determined them to be overfished and overfishing. And so what this basically tells you is that no matter what you do to menhaden, as long as the striped bass fishing mortality is at its current level, you aren't going to recover striped bass populations above the biomass target. Next slide. And so as part of the stock assessment process for striped bass, they had come up with a rebuilding fishing mortality target of 0.2. So now if we plot that line on our contour plot, we can see that there's a range of menhaden fishing mortality rates that would allow striped bass to reach its target and threshold values. And so this gets at what level do we want to sustain the predators at? And so these ERPs are based on fishing mortality rates that would not compromise the ability to reach the single species targets for striped bass under this rebuilding plan with the F of 0.2. Next slide. And so then we can also, where those points intersect those lines is how we define the ERP reference points. These are fishing mortality reference points. The target fishing mortality for Atlantic menhaden is where the fishing mortality rate meets the biomass target line, and the same for the threshold. Next slide. And so probably a better way to look at this is if we just take this slice of values along this fishing mortality rate, striped bass fishing mortality rate of 0.2, the target rate, and plot it as a trade-off curve. Next slide. And so here we can see how striped bass biomass responds to menhaden fishing when striped bass are fished at their F target. And so this is what we based the ERPs on again. So here you can see that we have the single species menhaden reference points are indicated in red. So those are the target and threshold fishing mortality reference points from the BAM stock assessment model. And the blue values are the ERP fishing mortality rates. And so we define these as the ERPF target is the maximum menhaden F that maintains striped bass at their biomass target over the long term. And the ERPF threshold is the maximum menhaden F that maintains striped bass at their biomass threshold. And for the sake of these simulations, the fishing mortality on all the other species was held constant at their 2017 value. And indeed, the ERP rates were more conservative than the single species values as expected. And they were about 30 to 40% lower than the single species reference points. But as Andre had mentioned, the commission had already taken some proactive measures, and that green line that's indicated there is the current fishing mortality rate. And so even though these ERPF targets were big reductions relative to the single species reference points, they were about equal to or even a little bit higher from the current fishing mortality rate that have been prescribed already. Next slide. And so those reference points, as Andre had mentioned, they eventually were reviewed by the Menhaden Management Board and passed by unanimous vote in, I believe it was August of 2020. And so there were some discussions prior to that vote and afterwards that I think were really interesting. And one of the questions that the board asked us, where we had to go back and do some additional runs, was what if Atlantic herring were to recover to their target biomass levels? And so what this is essentially reflects is, the different assumptions about future ecosystem conditions may lead to different ERPs. And so when we first ran this scenario with allowing herring to rebuild to their biomass target, we actually got some results that were unexpected. And so we see that now with herring at their biomass target, you can fish menhaden as hard as you want, and it doesn't bring striped bass below the threshold. But then as we dug deeper into the model, we realized that those ERPs were very sensitive to the status of Atlantic herring. And part of the problem with the model at the time was that we were not accounting for seasonality. And so the model actually had striped bass eating Atlantic herring at about 30% year round, whereas we know that it's a seasonal interaction and they don't actually feed on them that much. And so we did some additional runs where we attempted to include that seasonality, and that reduced the discrepancies between these three lines here. So the black line is what I presented before. The green line would be if herring were at their biomass targets, and the red line is if herring are at the biomass threshold. And so it was very sensitive to what we did with herring, but when we included the seasonality, those lines all tightened up. And I think that gave us a lot more confidence that one, the model was performing as we might expect it, and two, we knew why, we were able to explain why we had this big discrepancy. So next slide. And so after all of that, we felt like this was, in some ways, it was only incremental progress, but it was also a very first step towards EBFM. And so we believe that these models will continue to evolve over time and become more holistic and probably eventually build back up to the full model that Andre had eventually developed, because right now we're taking a somewhat limited view. There's a lot of other components of the ecosystem that people care about that weren't addressed in this first round of ERPs. And I think the comments from the board suggest that those broader ecosystem considerations are indeed of interest. And so both the models and the management structure are going to need to adapt going forward. Next slide. And some of the key lessons learned, and this is from the Chris and Onsted's paper that was published in Frontiers. Some of the key lessons learned, challenges and lessons learned from all this approach. I think the first challenge that we faced was the lack of clear ecosystem objectives to guide the ERPs. And, Andre mentioned the workshop that happened in 2015, but I would say that workshop was probably about 5 years, was the result of 5 years of back and forth between the technical committees and the managers trying to understand what their objectives were. And ultimately, when they invested in the workshop with stakeholders, were we able to kind of get some traction there. The next challenge is getting and vetting data streams for these models. One of the reasons of going to the mice model is that it definitely overcame a lot of the challenges, because we're only including species that had mostly had stock assessments. So all those data streams were pretty much available. and were able to be made available by the stock assessment committees. But there were some issues with the timing. The stock assessments aren't all on the same schedule, and so we had differences in years and things that we, just some minor hurdles to overcome. Another challenge is understanding and quantifying uncertainty. I think this first round we focused on this multi-model approach, which I think was really smart of us as a group to do this and include them all in the review report that went out for review, because it showed where the models were, where there was coherence among the models, and I think that gave the review panel a lot more confidence and comfort in passing the base model. But I will say there's still a lot of work to do as far as quantifying uncertainty, and there's a number of areas where uncertainty needs to be quantified. But ultimately, we need to be thinking about incorporating uncertainty in some form of risk level advice. The next challenge is that these ecosystem models require significant levels of expertise, funding, and time. In some ways, none of this, I don't think we would be here if it wasn't for the external funding that has been provided by Pew and Lenfest and others that set the foundation for the ecosystem modeling that Andre did, and also provided support through the development of these ERPs. And also, just recognizing that the AFSMSC and the ERP Work Group is composed of mostly mostly state scientists who all have other jobs. And so I think it's something to think about moving forward, that it is going to take a significant time commitment to maintain these models and keep them updated. And maybe the model of the ERP Work Group of kind of using state scientist time might not be sufficient. So we need to think about dedicated efforts for these ecosystem models. And then the last thing is the challenge is this paradigm shift in the assessment and management. And we were able to do these ERPs this time, and there could be changes if as I mentioned before, there's questions about other species, and you can go to the next slide. And what I mean by the kind of structural changes within the management is that right now each species that is managed by Atlantic States has their own management board and their own technical committee, and they don't interact. Next slide. And so to actually get to true or full, more full ecosystem-based fisheries management will require some integration and feedback among these single species management boards, where they all come to the table and talk about what their target biomass levels, and what do we want each of these species to look like, and then how can we optimize the harvest of each species. Because as you start to rebuild striped bass, and if you read the paper in Frontiers, as striped bass start to get closer to their target biomass, they start to actually have top-down effects on weak fish, and bluefish has an effect on striped bass. So these species are connected in more ways than just menhaden. Next slide. And so that kind of sums up how we got to the ERPs. And I do want to acknowledge the Lenfest Ocean Program for funding this work, and as well as the PIs on that project, Andre, Ed Hood, and Tom Miller, and Amy Schuler from the Beaufort Lab. And then I just also want to give a shout out to the ERP Work Group. This group has been together for a long time now, and I have to say this is probably my favorite committee to serve on. We get together, we do work, we're very productive. We share the responsibilities, and it's just been a great group to work with. And I think that everybody on that group has contributed in some way or another to these ERP development. And next slide, I think that's, yep, so here are some of the key references, and I think we move on to Daniel.
Okay, can people hear me before I start talking? I find out, I guess. So I've been invited to give this next part of the talk, and it will sound initially as if I'm speaking about something completely different, but I'm really not, and I hope you will see this fairly quickly. So can we have next slide? So the work in the Irish Sea had the same overall goal, that we really want to use ecosystem information in our fisheries management. We want to find a way of fitting this ecosystem information into the existing management scheme rather than waiting 50 years until someone comes up with a new way of managing. We can't do everything within the existing management, but surely we can make some progress. So next slide. So I just need to tell you a little bit about what our management scheme is. There's two layers to this. ICES is the body which in Europe provides the fisheries advice. And the key requirement in ICES is that all advice is precautionary. There's a secondary goal for good yield, but the main one is don't crash the stock. The details are different to how it's done in the US, but the principle is the same. Next slide. And on top of that, the management is, at the time we did this, was the European Union. So the European Union also has this precautionary requirement. It also has a requirement to aim at maximum sustainable fishing, but it has a thing called an FMSY range, where instead of fishing exactly as hard as you would get the most yield, there's a range around it. The range says that you get within 5% of your maximum yield over the long term and without imposing any undue risk of stock collapse. It was originally designed to accommodate the need for mixed fisheries where you catch more than one fish at the same time. So you need a little bit of flexibility in your quota setting, but that flexibility is there and we can do other things with it. So let's move on. Next slide. Yeah. So what's on the screen at the moment is how most fisheries management works at the moment. We work within a single species world. We create a single species model, which tells us how the population is now and how it got there. We use this to estimate limit and target reference points, how hard we want to fish, levels of fishing that we definitely don't want to go beyond, and biomasses that we definitely don't want to go below. You then might adjust that target F a little bit. If you're at a very low state at the moment, you might want to reduce your fishing pressure to allow for rebuilding. You then run the model forwards for typically 1 year to see what's likely to happen next year, apply your target fishing mortality, and then you get your quota advice. And that's what we do now. Next slide. You could come up with a similar series of steps in creating an ecosystem model. I won't go through the details, but it's effectively the same thing. What are we trying to model? Make the model, check it. But there's a gap between them. There's this white space between them. The single species model and the ecosystem models have always lived completely separately. And what's just been shown in Menhaden is the same kind of thing that's being proposed in the Irish Sea, although for different reasons. Next slide, which is to put this thin link from the one to the other. The single species model does what it does incredibly well. They're fast, they're robust, they're relatively easy to understand and track down errors. So we don't want to throw away the single species model, but we do want to bring in ecosystem information. So what was done in Menhaden and what's being proposed in the Irish Sea and somewhere else is to use the ecosystem model simply to adjust the target F. You keep everything else the way you do your management within the single species model, but with an extra step that adjusts how hard you fish to account for what you need to do in the ecosystem. So in Menhaden, this was to allow sufficient food for the predators. Next slide. Next slide. Can I have another slide, please? There we go. No, you've gone two. It's okay. So in the Irish Sea, the goal was a little bit different. So there's been major changes in ecosystem functioning. There was a period where many stocks had poor recruitment together, and then that reversed. So there's been significant changes in the environment, not one directional changes, but probably associated with the North Atlantic oscillations. The assessment models are tuned over all these decades of data, and we want some flexibility to target how we fish based on shorter term environmental fluctuations. Next slide. So here the aim was to adjust the target F within these existing FMSY ranges. So these are the ranges that they come from the single species models. They fit the EU management requirements. They fit the ICES precautionarity requirements. So they're things that we already use. And as long as we stay within them, we stay within the management system. What we wanted to do here was to identify indicators of productivity for the different stocks. We used, again, an ecopath model to do this. Some of the indicators we came up with are what you traditionally think of as indicators, sea surface temperature. Some of them were not. Some of them were synthetic things created from the model. And if we go to the next slide, I will show you what I mean. So here are 4 of the stocks that we're talking about. Herring and cod, the graphs look the same because what's being shown there is not the biomass of herring or cod, but the indicator status that was identified for that stock. So for both herring and cod, for herring, it's the large zooplankton index. The amount of food seemed to be the thing that drove the herring. And there's been periods around 2000 when there was little food, and other periods in more recently when there was lots of food. So it's the next 2 that are the same. Cod and whiting both seem to be most closely associated with sea surface temperature, which seemed to be driving how successful their recruitment was. And finally, at the bottom, Nephrops was most closely associated with predator biomass, aggregated predator. So what we were proposing is that when you're at a state of poor productivity for a stock, you should be fishing at the lower end of the predetermined range. When you're at a high state of productivity for the stock, you can fish at a higher end of the range, but without crossing any of these pre-calculated boundaries. So carry on, next. I just want to jump briefly into the Baltic. Now the Baltic is somewhere between a lake and an ocean. It's almost closed, has limited interchange with the North Sea, and it has basically 1 key predator and 2 key forage species. So it's a fairly simple interactions. So there's a very long history of understanding here that the system has strong interactions that really matter, that as you change what happens to one of these 3 stocks, the other 2 respond. So next slide. So the Baltic proposed this figure here, which I'm not going through the details, but is very, very similar to the one I showed you that applied to the Irish Sea and to the Menhaden. On the left is the single species system as it works at the moment. On the right is what they're proposing, where they have, in this case, integrated advice evaluation, which largely is going to mean some kind of modeling, which then feeds into the single species workflow. So although this is, again, completely independent, it ends up being the same idea that you run all your single species assessment cycle as you do now, but with an input from the ecosystem information. So next slide. So let's not forget that single species management models actually work well. The main problems we've had with them are where the advice hasn't been implemented. They really do mostly work. Sometimes they have problems, but we don't want to lose the benefits that they do bring. Equally, they don't do everything that they want, not as we're moving towards ecosystem-based management. They clearly can't do that. So we need to bring in a wider picture into the advice. So what was done for the Menhaden and what's been proposed across the Atlantic is a method for allowing the ecosystem information, generally synthesized through an ecosystem model, to modify how hard we fish that lets this happen. It keeps the strengths of the single species management we have now, and it builds on that. It doesn't throw it away, and it doesn't break anything. We don't allow fishing to reach unsustainable levels. In the Menhaden example, we're only talking about reducing fishing, and in the Irish Sea, we're talking about not going beyond the pre-calculated safe limits. Next. Now, the 3 examples I've showed you had no knowledge of each other whatsoever. The Menhaden work happened by itself. The Irish Sea work happened by itself. I was involved in the Irish Sea work and then happened to be a reviewer for the Menhaden work. And the work in the Baltic was equally independent. So if 3 different groups have essentially come up with the same idea, then it is suggesting that it's an idea whose time has come, that our ability to do this modeling has advanced to the point where this is a feasible way of integrating at least some ecosystem information into our management. Now, it's not by any means the end game. There's a whole load of things that it doesn't do, but it is definitely a step along the road. It's flexible to different requirements. The reason for me showing you the Irish Sea was to show you that the same scheme can be expanded outwards to address pretty much anything that your ecosystem models can simulate realistically. And the important thing is that it's a step we can take now. Because we stick within the single species management most of the way, it fits within the existing regulatory frameworks. And I think that was me. Yep.
So my name is Karen Abrams, and I will be talking to you a little bit more from a management perspective, building off of the presentations you just heard. I'm with NOAA Fisheries. I was not on the ERP work group or the Menhaden Technical Panel, but I do work in NOAA Fisheries. And one of my roles in NOAA Fisheries is to coordinate with many others our US efforts nationally to implement ecosystem-based fisheries management across all of our fisheries. So I come to this panel with a national EBFM perspective from NOAA Fisheries. And while Menhaden is an interstate fishery managed by the Atlantic States Marine Fisheries Commission, there are a lot of lessons from the Menhaden experience that could be applicable to other federal fishery management work we do with our Federal Fishery Management Council partners. So in particular, we can learn from the Menhaden example as a manageable and practical way to assess trade-offs between managed stocks, take broader ecosystem objectives into account while achieving sustainable fisheries goals, which are among the core tenets of ecosystem-based fisheries management. Next slide, please. So what is NOAA's fisheries position on ecosystem-based fisheries management, and why even do it? EBFM, as we've heard, can be quite difficult, multifaceted, complex as compared to single species management. But the need to manage fisheries under multiple mandates, prepare for changing ocean conditions, particularly climate change, assess trade-offs and decision-making, among other issues, continues to grow as pressures on our fishery resources increase and become more complex. Next slide, please. So the area of ecosystem-based fisheries management has been an area of interest for NOAA Fisheries and our partners for a while. And together we have actually taken a number of steps moving towards an ecosystem-based fisheries management approach over many years. But the approach has been somewhat ad hoc and slightly diffuse until recently. And that in 2016, the agency formalized its commitment to ecosystem-based fisheries management in two important documents. One, in 2016, we established a policy that lays out a definition for EBFM, the agency's commitment to EBFM as an approach for achieving sustainable fisheries management goals, and identifies 6 principles to guide those efforts under multiple mandates. The primary mandate for federal fisheries in the US is the Magnuson-Stevens Act, but we are required to implement the provisions under the Magnuson Act while also adhering to many other requirements and mandates under, for example, the Endangered Species Act, Marine Mammal Protection Act, NEPA, et cetera. So the other document to highlight is in 2016, the agency finalized the EBFM roadmap, which lays out an aspirational path for actually implementing these principles. Next slide. So what are these principles? The principles established in the EBFM policy there are 6 guiding principles, and they create a transparent, stepwise, and systematic framework for implementing EBFM. The principles also establish a framework that diverse incremental steps towards EBFM around the country can fit into, and that as an agency with our partners, we can build off of. So if you look, so the principles start from the ground level, touching on many of the themes that you just heard about today. You know, fundamentally, first, what are the objectives? What's the foundational science? How do we set our priorities? What are the options? How do we explore the trade-offs? What is the management advice? And implementing these steps get us to the outcome of maintaining resilient marine ecosystems. So step 4, what are our options? This is where I see the Menhaden example with the ecological reference point model that we just heard about ties directly into the principles that NOAA Fisheries has established with this EBFM policy. Next slide, please. So from a management perspective, I just would like to highlight some of the aspects that we've heard about today from the Menhaden example that I think are especially relevant when we think about leveraging the Menhaden example into potentially other fisheries contexts under an EBFM framework like the one I just described. So critically important, obviously, is the establishment of management objectives as early on in the process as possible, which requires the involvement of stakeholders, many stakeholders. And as we heard, the earlier that's done, the better it helps inform the modeling decisions about designing the models, and that streamlines everything. So that's a step that is critical and is consistent with the guiding principles that we follow under our EBFM policy. We also heard about the value of using two different models in tandem to provide different kinds of advice, providing the long-term strategic direction that comes out of models like the ecological reference point approach, and also the traditional stock assessment models that provide the immediate catch advice. So what I think is relevant here is I think we just heard about this as well in a previous presentation, is that it's an approach that doesn't completely throw out the single species approach, but builds and enhances on it, which might be incremental, but it's practical and offers practical advantages that can be more easily implemented than throwing everything out and starting from scratch. We also heard about the challenges of finding the right model. Selecting a model with enough complexity that responds to the management questions, but that's also workable. And these models of intermediate complexity offer a lot of potential in finding that appropriate space in a management context. The value from a decision-making standpoint of Menhaden is it's self-managed along with striped bass, which is also managed. And in this particular example, both managed by the same management entity, the Atlantic States Marine Fisheries Commission, is something that may be applicable in other areas. There's a complicated process, but having the same management entity involved and responsible for both of those species does help, and may be more complicated in other areas. So next slide, please. So the approach used for Menhaden is a really important additional option for approaches that NOAA Fisheries and our partners have already been involved with in the management of forage fish, primarily with fishery management councils. And so it complements and adds to other efforts to manage forage that are already underway in different ways under the Magnuson-Stevens Act. And there are a number of examples, like the work that the Mid-Atlantic Fishery Management Council has done in 2016 to prohibit the development of directed fisheries on forage fish until the council has an opportunity to evaluate scientific information on the potential impacts of the fishery. The work that's been done on the West Coast to limit directed commercial fishing on unmanaged forage fish species. And there's work that's happened in many areas, also in Alaska, using ecosystem component species under National Standard 1 under the Magnuson-Stevens Act. Those are examples, though, that they're effective. They're less dynamic than the Menhaden example that we've seen. And so the Menhaden example really does offer another powerful tool and approach in a dynamic, practical way to conserve and manage forage fisheries in the context of the management construct that we have. Next slide, please. There are, of course, challenges that as we think about how to apply the Menhaden example elsewhere, there will be challenges we'll have to address. One is just change is hard, and As EBFM is implemented, it is asking a system to really think differently about fisheries management. Stakeholder involvement is absolutely critical, and it's difficult to get buy-in when it's not really clear what those short-term trade-offs are for taking on the additional complexity and cost that comes with using EBFM types of approaches, including, as we heard, the Menhaden example. So, that is a challenge, but is one that's consistent with when we look at examples and trying to apply them nationally in any kind of context. Next slide. And then the other common challenge, and I think it applies in this case as well, is that in the US, we manage a wide range and diversity of fisheries. We're responsible for over 460 stocks managed fisheries, and they're very diverse fisheries, very diverse ecosystems, very diverse kinds of data available for each of those fisheries. And so very difficult to apply a one size fits all. So that means that that adjustments will have to be made to take into account the specific needs of each fishery and be responsive to the management objectives that stakeholders identify in their particular region. So again, this is a common theme in fisheries management. One size does generally not fit all exactly the same everywhere. But the Menhaden model and example is a really wonderful example of how diverse partners working together can produce a really effective modeling solution to respond to specific management objectives. And I believe it offers a lot of potential for leveraging in the context of our fisheries nationally. So thank you very much.
Hey, everybody. I know we are at 2 o'clock right now, but we covered a lot of ground. And panelists, if you can stay on for just a couple questions, what I wanted to do was ask, like, basically the two that in different forms were asked multiple times. And so I figure we could go with that. And attendees that have stayed, thank you for staying. The first question, actually the very first question, was asked by a couple of different people. How are the Menhaden ecosystem reference points affected by climate change? And then the last half of his question is, and the replacement of the grazing food chain by the microbial food web in the Gulf of Maine ecosystem food web for forage fish. And that question about climate change and the Erps is asked a couple of times below. So I wanted to put that one out there for the panel.
Yeah, I could take the first crack and folks can join in as needed. I think that's a great question and certainly a clear direction to take this, right? You always have to kind of start with the foundation and add complexity. And you heard that theme as we've been talking, right? We try one thing and then kind of modify it and try to find that sweet spot. So in the current versions of these models, we don't account for climate change or anything like that, but the foundation is there. Actually, Max Greslick, a master's student with me, is working on his thesis. And one of the things he's doing is looking at projecting the full ecosystem model under different primary production scenarios that are expected with climate change. And so he's looking at what some of the implications of that would be on the outcomes, the winners, the losers, and those trade-off plots. So great question, and certainly a direction that we want to take this.
Yeah, and I'll just add to that, you know, part of the reason several of us on the work group were advocating for the EcoPath with EcoSim approach is because it does have the ability to include these bottom-up drivers, and none of the other models did. And so that's definitely something that's in the future. And I know that some of the questions that have come from the board recently have actually touched on these more spatially explicit questions as well as climate change. And so that's probably something that we'll be building into the next 1 or 2 iterations of this.
And the example I showed in the IRC, although it's not specifically looking at global warming as change, it's looking at environmental changes in general. So the overall approach works just fine. It's about identifying things that are strong enough to be usable, but the structure is solid for that.
Great. And I think the second question before we jump off, because I know people have other things to move on to, but this was also asked in different forms, which is, as you said, getting all stakeholders to agree on a manageable list of objectives is very time consuming. Are there any lessons learned that you can pass on from this experience? And kind of related to that, someone else also asked, how do scientists in particular work to encourage change in the governance system across all boards? So getting those stakeholders together and the role of science in that, if you guys have lessons learned or insights from that.
I could take a first crack. With the ecosystem objectives, I actually think a lot of those, we kind of knew what they were. Like I remember starting the work and, I could kind of guess, we want to sustain menhaden for predators. So I actually don't think it's as time consuming, right? It's a 2-day workshop. There were certainly a lot of people have been thinking about it for a while. I think having it be a guided process was very important, with the external moderator. But I think opening those lines of communication and having that dialogue is really important. And to touch on that second point, like how the science can kind of help generate change in the systems, there was a lot of push from the scientists saying, hey, we need more guidance and direction. And it, as Dave pointed out, it took a long time to get there. So I think starting that process sooner is key, but the constant feedback of the scientists saying, hey, we need this, we need that. I think it's that ongoing constant struggle, but it would be nice if we could have that be more efficient. And hopefully other regions and fisheries can learn from this example.
I would just add too that this issue of objectives isn't unique to ecosystem-based management. I mean, their single species has the same challenge. What are the management objectives? And just to the second point about how we can help facilitate that as scientists. I mean, I think that now that we have an operating model, that it provides sort of a platform to bring managers of different species or stakeholders with interest in different species around the table, kind of in a scoping workshop type phase to talk about the next steps. And so we should use these models to help guide that process as well.
And I would just add that as a policy person, I'm not a PhD scientist. Bridging the conversation between the PhD scientists and the policy people is really important, and hearing from the science community and communicating with each other about what the policy constraints are with the scientists, that helps a lot to gain a better understanding of how we can move all of this together forward.
Great. And so, I'm sorry we didn't get to all the questions. We will be downloading them and can certainly follow up with folks. Please do stay in touch. I want to thank everybody for joining us today. I want to thank the panelists for all of your work to put together these presentations. This was a great reflection and also looking forward. So thank you everybody for joining us today, and we will conclude. Sarah?
Okay, thank you everyone.